Hi everyone, my name is Caleb Flanagan and I am the Group 1 reporter for the bomb calorimeter experiment. So a little introduction about the experiment. So we're going to want to discover the thermal capacitance of the bomb calorimeter and the heating value of an unknown fuel. Also, we're going to use the first law of thermodynamics for the heat of combustion associated with the calorimeter. The equation is the heat of combustion equals the thermal capacitance times the change in temperature. And the change in temperature of the water surrounding the capsule heating up by the heat transfer is recorded over a span of time. Also, when the two fuels are burned, known and unknown, the heat of combustion for the unknown fuel can be determined with the thermal capacitance of the calorimeter, and that's used by solving that equation. The thermal capacitance of the calorimeter is equal to the total heat of combustion over the change in temperature. So here are the apparatus and materials. So we have the overall diagram of the bomb calorimeter. We have the igniter on the right. We have the stainless steel bomb, which is number 2. We have the laptop and the PDEC view installed and the analog to digital converter up on the top left. We have the water bucket, which is number 5. We have the thermocouple, which is 6, and the water stir motor, which is number 7. Also on the side you have the oxygen tank and the fuel sources, the scale, and the fuse wire. Here's a detailed view of the bomb. So 1A, we have the inlet check valve, 1B, the pressure relief valve, 1C, the electrode terminals, 1D, the crucible, 1E, the 2 electrodes, 1F is the ignition wire, 2 is the bomb housing, and 3 is the locking lid ring. So here's a little short procedure summary. So first we're going to prepare the bomb. We're going to assemble the bomb with the ignition wire and the fuel sample. Then we're going to prepare the water, fill it with 100 milliliters of water. Then we're going to open the PDAC. We're going to assemble the bomb, which is placing it in the water tank. And then we're going to record this experiment and press the ignition button on the PDAC. And you got to wait for the temperatures to get high enough. And then we're going to shut everything down, take the water out, and clean up the mess. So here is the 2 fuel samples of benzoic acid and the unknown fuel, and then we have the ignition wire. So here is the results for the benzoic acid. So we had 1 gram of the benzoic tablet. We have the ignition wire. The initial length is 10 centimeters, and then we had the final length of ignition wire, which is 3.478 centimeters. So we want to find the thermal capacitance of the calorimeter. So the thermal capacitance is the total heat of combustion over the change in temperature. And then plugging in the values, we get that the thermal capacitance is 11.825 kilojoules per degrees Celsius. And on the right is the graph. I took our results and graphed the temperature versus time. So here we have the results for our unknown fuel, which is a Skittle gummy. So the mass of that was 1 gram. We weighed that on the scale. We have the initial length of the ignition wire, which is 10 centimeters. Again, we have the final length, which is 4.03 centimeters. And we want to find the heating value of the unknown fuel. So we know that the total heat combustion is the heat combustion of the fuel plus the heat combustion of the wire, which is equal to the high heating value of fuel times the mass of the fuel plus the high heating value of the wire times the mass of the wire. Below is the other equation we've been using, but just you isolated the total heating combustion on the left side. And then below we have the heating value of the fuel solved for, and that equals 18.626 kilojoules per gram. So here's a little discussion. So we have the heating value for the Skittle gummy, which I think that is the wrong value. I just changed it. But also we wanted to compare some other fuel sources, similar, some not so similar. So we have the charcoal heating value, which is 26.7 kilojoules per gram. We also have dry wood, which is the closest heating value to the Skittle gummy. It's 14.7 kilojoules per gram. We have gasoline and natural gas, which are around 50 kilojoules per gram. Also a little discussion, some questions that were asked. Why do we circulate the water in the bomb tank? So we want to even out the temperature throughout the water as the bomb is ignited to get an accurate reading. Also, why do we use 2 fuel sources? So we can get the thermal capacitance of the calorimeter. last question is, what is the difference between the higher heating value and the lower heating value? So the higher heating value is calculated with water being in the liquid phase, and the lower heating value is calculated with the water being in the vapor phase, which is a much higher number. And then we have a couple of our references.